Alright guys, here's a question from chapter 11 section 1. This is number 16. And so it says, a physical therapist wants to determine the difference in the proportions of men and women who participate in regular sustained physical activity. And they want to know sample size and within 3 percentage points within 99% confidence. So we can actually do this on StatCrunch to figure out sample size. And we could have done it in chapter 9 as well. I think we did do this in chapter 9. But when I do a T-stat and do a two-paired, I'm doing proportion, sorry, a proportion with two samples, I can go to power or sample size. So I'm looking for sample size in this case. So I need to do a confidence interval width, and then I'm just going to plug in some information. So it says I have 21.6% male and then 19.7% female. I want to be 99% confident and within 3 percentage points. So within 3 percentage points means plus or minus 3 percentage points. So that's all the data they gave us. There's our percentages, 99% confidence, and within 3 percentage points. So when I plug this information in, I do just that. My first proportion was the 21.6%. My second for women was 19.7%, so 0.197. And my width is going to be 0.06 because it's plus or minus 0.03, 3 percentage points. And when I do that, it tells me what my sample size needs to be. It needs to be huge, 2,415 needs to be my sample size. But that's just a way that StatCrunch will do the calculation. There is a formula for that. You can use that formula on the test if you want. But again, this does all the math for us. It does the formula for us. We just have to type in the information. If we do not have any prior estimates, when we go back to this, we don't know what males and females are going to say, so what we have to assume is that it's 50%. That's what we have to assume if there's no prior information given to us. Again, I'm going to change this back to 0.06. Still at 99% confident, and we're going to get a larger one. Whenever you don't know a previous proportion, you go with the 50% and it will always give you your largest value. So 3687 would be the most that we would need to survey to get a 99% confidence interval. And I've already forgotten what that number was. 3687. So you can find the formulas to do this in section 1, but honestly, let's use the technology. The next one I had was from section 2, and it was just looking at some of the first couple that they had. So let's look at those. So 11 section 2, and the one that was asked was number 2. So let's look at that one. And it's asking to find the difference, right? Because in section 2 we're talking about dependent samples, and so this is how you would actually have to do this by hand if we were doing it. We would subtract our x value minus our y value. So if we subtract those, I would get negative 1.7 would be my first one. My next one would be negative 0.8. These are my differences between my x values and my y values. It would be negative 4.4. I'm doing these off the top of my head, so hopefully I'm not doing it wrong. Negative 5.1, negative 1.9, negative 1.8, negative 4.7, and negative 2.7. So those are my differences. Whoops, and I did something wrong. At least one of your answers is incorrect. Alright, so that one's 1.7, that one's right. That one's 0.8, I'm good with that one. That one's 4.4, 5.1, 1.9, 1, that one's wrong. That one's 2.2. Apologies, 2.2. That one is 4.7 and that one is 2.7. So let's check it again. Got to make sure we do good subtraction. And then it says compute the mean of these things. So if I had to compute the mean of these things, like I would add them up and divide by 8. So let's go through this and figure out how we can do StatCrunch to do this real quick for us and get all our information. We're looking at a t-stat of paired or dependent samples. And so I think in the video I talked about for this section how we could click on this box and it'll give us our differences. And I think we're going to be doing a hypothesis test, but right now let's just find those values. So it gives me this difference column, all those values that we just typed in. If I want to find the mean and standard deviation, I could just do a summary stats of my differences. And I can get my mean and my standard deviation. So let's type those in. The mean difference is negative 3 decimal places, so 938, negative 2.938. And then my standard deviation we found is 1.590. 1.590. Now we're going to make the alternative hypothesis, or state the hypothesis. So it's always going to be the mean difference is equal to 0, and there's only one to pick. Our alternative is saying that it's less than 0. I don't know how we would. It looks like it's less than 0, but test if MD is less than 0. There we go. So that's what we're going to put there. Again, our mean difference is always equal 0, and they told us less than 0. Now we're looking at part D and find the p-value. So let's go back here and do this hypothesis test again. So we took our data, our stat, t-stat was from paired dependent samples. My first one was my x's, my second one was my y's, because that's what they told me. And then we can just do our hypothesis test now and say it's less than 0. This will give us our p-value, which is 0.0006. So the 3 decimal place would be 0.001. And then now, since it's so small, our p is low, so the ho got to go. And again, we're looking at alpha is 0.05. So my p-value is lower than my alpha. So I'm going to reject the null hypothesis. And when I reject the null hypothesis, there is sufficient evidence. So, again, when you're doing these dependent samples, that would be the process if you're doing by hand. Actually subtract all those values, find the standard deviation and the mean of it. Again, we're going to use the technology to do most of it for us. And it'll find our p-value, and we can say, hey, these two things are different, right? There is enough difference in between them to say that they are different sets. They come from different sets of data. So, hope this has helped with the homework, and y'all have a good night.